graphs that look a lot like pizza, and what is Mr. Hawkins' favorite candy bar? These questions will be answered and many more on today's Moment of Science. Last time on Moment of Science, we kind of looked at how we can record data and why it's important that we record data. And today what we're going to be doing is actually drawing conclusions from the data that we may have recorded, okay? Usually, we take our data into a table, okay, and it looks a lot like what you'll see right here, okay? If you'll look real closely, you'll see 3 different types of Alka-Seltzer sizes and 3 different types of times that came with the size of the Alka-Seltzer, okay? The time of the reaction, as you can see right here, was 7:46 seconds for a whole Alka-Seltzer and 7:50 on the second trial, okay? As you can see, 6:50 for a half of an Alka-Seltzer, 6:43 for half of an Alka-Seltzer, really close together, right? Okay, and for the powdered Alka-Seltzer, you can see the times are really, really close, within 3 seconds of one another. So, a conclusion that you could draw from this would be that maybe, okay, the more powdery the Alka-Seltzer is, the faster it dissolves in water, okay? That's a conclusion that could be drawn from strictly the data alone, if you knew the procedure, right? Okay, now we can actually take that data and turn it into graphs, okay, and you will have to do that a lot. So, when you do take the data that you would see in that chart and put it into a graph, it would look a lot like this. Okay, if you look real closely, you'll see on this axis we have a number of minutes, and on this side, this axis, we have the trials. If you'll look closely, 3 different colors over here, okay, as we had 3 different types of Alka-Seltzer that we were using in the experiment, right? Now, do these graphs look similar to one another? If you take a second and actually look, they do, okay? This is a bar graph, okay? Bar graphs are good for representing things and comparing things. They're a good measure of comparison. And you can see that the whole Alka-Seltzer took a lot longer to dissolve than the powdered one, okay? We can keep that conclusion that we got from just looking at the data. And all we had to do was understand that the data tells us something, okay? The numbers that you see in anything always have a purpose, okay? They tell you why we did the things we did and what actually occurred based on what we did. All right, so data is part of science. It's really important, and we can use them and put them into graphs based off of a chart and vice versa, okay? We can do that kind of stuff. Now, there are different types of graphs. If you look above me, you're going to see a line graph, okay? Line graphs look a lot like this, and if you look real closely, it is a measure of the average gas price over the span of a year, okay? And if you'll look, you'll kind of see that the gas prices kind of stayed close to $3 for the majority of the year. And as we got towards the summer months, May, June, July, and August, it kind of spiked up, right? Okay, if you'll notice, there's a later spike, and I want you to kind of jot down in your notes what you think that second spike may have came from. Okay, you'll notice it's close to November, okay, in the November month. So, there's a second spike for some reason, and we can draw a conclusion based on that, where it came from, and that's what I'm asking you to do in your notes, okay? You'll see that the average price of gas, you can draw that conclusion, was never lower than $3, okay, which is very important. And that's the case, that's the way it always is, I guess, guys. Sorry about you. That's the way it's going to be for a while. But the average price of gas never drops below that $3 mark. That's a conclusion we can draw. Okay, you can draw all kinds of conclusions based on this graph above. You can probably draw the conclusion that Mr. Hawkins can't draw. Shocking. But, okay, that's a conclusion we can actually draw from the graph, off of a line graph alone.
The graph that you'll see above me this time is a pie graph. Looks like a pizza pie, yeah? Okay, so it's divided up into little pieces, and they vary, okay? The pie graphs are really good for showing you percentages, okay? That's the way that you always want to represent your percents, is through a pie graph. Okay, now let's say that this graph, as you can read, tells you Mr. Hawkins candy bar consumption. All right? Right now, if you look, the red one tells you the amount of tells you the amount of Butterfingers that I ate. Okay, the black color tells you the amount of cookies and cream candy bars I ate. And the blue one tells you the amount of Reese's that I ate, okay? So if you look at that graph, take a few seconds, jot down what you think my favorite candy bar would be based on the consumption that I had, okay? As you do that, you're making a conclusion, okay? You're drawing a conclusion based on data that you see in a graph.
In class, so we can determine if your conclusions are correct or not. But until then, we'll see you next time. This has been Mr. Hawkins, and this has been a Moment of Science.